Convection, radiation are the three forms of thermal transfer that we deal with. Notice I have two blocks, block A, block B. I don't have a way obviously on YouTube to prove the feel of the blocks. This one feels colder to the touch than this one does. If I take two pieces of ice and I put them on the two blocks, we notice, if you need to stand up and see that better, you'll notice that what's happening, this one is melting and this one is not melting. The reason for that is, this is a conductor and this is an insulator. How can we, again, it does feel colder to the touch. Why? Because it takes the heat from your skin faster. That's what a conductor does, is it conducts away the heat, while an insulator does not conduct away the heat as fast. It will conduct it, just slower. Now if I take that same piece, a different piece of ice, and I put it over here, it will melt just as fast. Now another way of proving that would be to take a different piece of metal, say this box right here, which is made out of metal, and say this glove here that we use for holding hot things. If I take those, move these out of the way, and I put a piece of ice here, and a piece of ice here, once again you notice that this one is melting. Why? Because it's on a piece of metal. It's not that it's a different temperature, they're in the room, they must be the same temperature. Just like a cup of hot coffee and an ice cube, put it in the same room for a significant amount of time, will come to thermal equilibrium, the same temperature as the room. But being a conductor, it takes the heat from the room and passes through the conductor to the ice cube faster. While this one, notice it has hardly changed at all because it's a very good insulator. Conduction tends to occur between is heat of touch, mostly through solids. But what about convection? Convection occurs in fluids. So let's start off and notice I've got a candle and I've got a couple of stove pipes here. Let's take a look. If I light the candle, I put it inside. Put the stove pipes on. Take a piece of paper and burn it. So, because I need a smoke source. And notice that the smoke is being drawn down the right-hand tube and is going to come up the left-hand tube. Why? Well, by convection, which is a difference of densities. The air above this candle is less dense because it's hotter, and so it rises, just like bubbles in water, and which must draw down the other side. Again, if you're moving matter here, then it has to create a vacuum which pulls some air in from somewhere else. Put that out by using the piece of metal. Now to show that one more way. So I'm going to put that in the mover for you, please. Okay, we do this a different way. If I take this tube, which has got water in it, and I start a Bunsen burner, use it out of the way here. I'll do good safety here and put on, someone can, there, that's good. Since I have the Bunsen burner on, well, we'll do this another time later on. Okay. Start with yellow dye. We'll notice the dye is starting to move this direction. Why? Because the heat is rising on this side, pushing it around the tube. Well, I can turn the tube and cause the convection to go the other direction. Heating this side, which will cause less dense water to rise, which will move the convection the other, oh, notice it stopped at the bottom, and now it's starting to drive it the other direction. Okay, now I can change from the yellow dye and change to a darker dye so that we can see it on top of it. That way I don't have to keep changing the water. We'll know which way is hotter by the way it begins to move. It's not really going anywhere, but we'll drive it that direction towards your left. I will turn it as soon as it starts to move, and we will drive it the other direction. Oh, not yet. Oh, there it is, starting to mix. There it goes. Convection. Less dense liquids or fluids rise, causing convection. And notice that it is turning this direction. Okay? Radiation. I don't have great radiation sources. The only one I have is the basic radiometer. If I take the radiometer, and I take a light source, the radiometer begins to move. I take it away, and there is a little pin there, a little needle, so that's just a bit of friction, so it will eventually slow down. There we go. Now, this truly is not moving because of radiation. A lot of people think that it's actually happening because the light source is hitting there and causing it to move. Well, by conservation of momentum, if light particles are hitting these veins, then the white veins should go forward. I don't have time to prove that right now, but if you hit something and the particles bounce backwards, then you have negative momentum. You must have a greater positive momentum, which would drive the whites forward. But instead the black is going forward. What I believe is happening is the black is absorbing the light, it's giving off puffs of air, which is causing convection and actually pushing it around. Okay? We'll go to the next thing after this. Stop. Okay. We're going to start another one here.